Welcome back to Science and Engineering, the Guide. Today we'll be discussing testing, gathering of data, and documentation. This is in regards to your experiment and is the second part relating to the experimentation section of your project. Now, in regards to experimental documentation, there are a few things to remember to document before, during, and after your experiment. Firstly, before you start your experiment, you need to complete your forms. This is essential because these forms are what allow you to participate in your competition. Things also get messy if you postpone filling out these forms. For example, there's a form that requires the date of starting your experiment, which gets more difficult to determine as you continue into your experimentation process. Pratham will take it from here.
So yeah, you should also have your materials and procedures completed by this time. There may be a situation where you run into an obstacle when trying to carry out your procedure. In this case, it's fine to adjust your procedure. Make sure to also add any additional materials or procedures you may not have initially included in your materials and procedure document. Then, during your experiment, you should take pictures of each significant step, which will help to visually document your experiment in your final report. Make sure there are no people in your pictures. Obviously, you should also record your data from your experiment. Then, after your experiment, you should document your data by compiling it into a table and then a graph. Then you'll have to develop an analysis of your data. We'll talk more about these tasks in our next video. Next, Jay will talk about testing.
Now, onto the actual testing part of your experiment. You should plan to run at least 3 trials because when conducting an experiment, there tends to be sources of error. These sources of error can be of varying degrees, so it's important to minimize it to the best extent. But regardless, there will always be a small source of error. To ensure that this source of error does not affect the accuracy of your data, scientists run multiple trials. The more trials, the better, but the least recommended amount is 3 trials. As mentioned earlier, be sure to take pictures of the significant parts of your experiment as you do them. These pictures shouldn't have any people in them. Next up, Seisha will talk about the gathering of data.
So gathering data is a very important part of your experiment because how you plan to execute this will have a significant impact on how you format the data in the future. In science and engineering, as a general principle, keeping your end goal in mind will always help you to go through the process of getting there properly and efficiently. In this case, the end goal of this step in the scientific method is to be able to collect accurate, pertinent data. This means that you have exact data and all the types of data that you need to analyze your experiment in the future. We'll go through an example of this now. So we're going to be making a table to house all the data that you're going to collect in your experiment. And you all have probably encountered a table like this before in your math classes when graphing an equation or something like that. And we're going to do something very similar here. We're using Google Sheets because it's very widely used and it's pretty accessible. So this is going to be your end goal for analyzing your data. So, but to get here, first of all, we need to have all the data graphed, all the data in a table so we can make this graph. Just to give you guys some prior knowledge about the specific example that we're going to do. Now, this is just an example, so your project will obviously vary from this, but we're going to be using data from an experiment that was about a balloon car. And the independent variable in this experiment was using plastic for the wheels or rubber for the wheels. And we were just testing which one drove the car to go further. So for an experiment like that, we'd first start off by naming the table of the data that we're going to be using. So we can do something like this here. This is the experiment name, and this will be used to name the table and the graph in the future. Then on the leftmost column, we're going to be running the trials of the experiment. So trial 1, trial 2, and trial 3. Remember that you should always have 3 trials for each independent variable of your experiment, as Jay mentioned, because you want to make sure that there are no flukes in your experiment. And you want to make sure that everything is consistent and practical data. But it's not enough to just have the three trials. We also need to denote which independent variable we're actually testing with each data point. So we're also going to have the types of independent variable at the top. So in this case, as I mentioned before, the independent variable of our experiment is whether the tire is made of plastic or for rubber. And our data points here are going to be used are going to be denoted in inches. So that's why we added the inches denotation over there. So from here, we can collect some data. So how this would work is you would run the balloon car experiment using a rubber tire 3 times. And say, for example, the first time we get the balloon car goes a distance of 6 inches. And we would note down 6 here. In the second trial, it goes 6.5 inches. And in the third trial, it goes 6.25 inches. Now we have data for the rubber tire in all 3 trials. And we can see that this avoids any flukes, because if the first trial were to be something like 15 inches, and then the remaining 2 trials were 6.5 and 6.25, then we would easily be able to understand that the first trial was a fluke and that there was something that was uncontrolled in our experiment that affected that. We can repeat the same process with the plastic tires. Here, this is the data that we collected for the plastic tires. So what this means is that the plastic tire car went 4.5 inches in the first trial, 5.25 inches in the second trial, and 5 inches in the third trial. But we also want to be able to understand on an overall point of view, how much distance did the rubber tire travel and did the plastic tire travel? And for that, we can use the average. So we can add another section here for the average. And here we can calculate the average of all 3 trials and paste it here. For the rubber tire, that was 6.25. And for the plastic tire, that's around 4.92. So what this tells us is that on average, the distance that the rubber tire traveled in all 3 trials came to about 6.25. This gives us kind of an overview of how much the rubber tire actually traveled, so we don't have to look at each and every data point for each and every comparison that we're going to make. And that goes for the same thing in the plastic tires. So from here, it's a common trap to be confused about where your dependent variable is represented in this table. Because as we can see here, this part is the independent variable, and this part is just talking about the trials. So where are my dependent variables? Well, the dependent variable is actually what you're measuring. So the dependent variable is your data. So the 6, 6.5, 4, 5.25, that's your dependent variable for that trial of your experiment. It's also a common trap to fall into to calculate the average using the 6 and 4.5 data points. In this scenario, you're calculating the average for trial 1, and that basically means nothing in most scenarios. So you want to make sure that you're calculating the average using the correct data points in order to have a good overview of what your project is actually doing. Now we're going to give you a template that looks similar to this. And this is kind of an overview of how an experiment would be in general. So here you would put your experiment name, the purpose of your table, and your independent variable in different levels. Finally, your 3 trials, your average for each trial, and you can record all your data points using the corresponding cells. So this is a general overview of how you would use a table in Google Sheets.
That brings us to the end of this video. Next time, we'll talk about your results, how to turn them into tables and graphs, and your data analysis. As always, if you have any questions, feel free to email us at the email on the screen or drop a comment below. This is Science Squad signing off. Thank you for watching. See you in the next one.